Welcome to the instructional video for Chapter 5, Business Finance, Interest and Compounding. The first thing we'll look at in this chapter is how to calculate simple interest. Simple interest is interest that is only paid one time on the amount borrowed or invested. So in looking at the interest formula, we see that I equals the interest gained, or interest that you have to pay if you're taking out a loan. PV stands for the present value, or the initial amount borrowed or invested. T stands for the time, always in years. And R stands for the rate as a decimal. So let's get started on the first problem. Tori loaned her brother $350 at 12% simple interest for 10 months. How much did her brother owe her in interest at the end of 10 months? That means that the interest will be applied on the amount borrowed at the end of that 10 months. So the first thing we need to do is pull out the pertinent information. The first thing that I notice is that Tori loaned her brother $350. That is going to represent the present value, or PV. That's how much is loaned today. So 350 is equal to the PV. The second thing I see is 12% simple interest. That's going to represent the rate as R equals 0.12. The rate is always a decimal. And the interest for 10 months is going to represent the time, or T equals, now 10 months is in months, and so I need to convert that to years. And I can do that by taking 10 and dividing it by 12. That decimal is actually 0.833. Now let's take our pieces of information and input them into our formula. I equals PV, or 350, times R, which is 0.12, and I like to put parentheses around them to designate that we're multiplying them together, and T equals 0.833. Now I'm going to keep 10 divided by 12 in my calculator and multiply that times 0.12 and then times 350. And what I have is the interest equals $35. That means at the end of 10 months, her brother is going to owe her $35 in interest, or $385 total. So that represents the calculation for simple interest on a loan. Let's look at simple interest on an investment. Simple interest is paid on bonds. So if you take a bond out for $7,500 over 30 years, you will receive payments each year of 7.3%. So the question says how much interest is paid over the life of the bond. Well, again, we're going to use I equals PVRT. And let's pull out the information. So PV equals 7,500. R equals 0.073. We take our decimal point over to the left 2 places to convert that to a decimal. And the time is going to equal 30 because they give us the information in years. So now I can plug everything in. I equals 7,500 times R, which is 0.073, times T, which is 30. And when I multiply that all together, the interest then is $16,425 over the life of the bond. That's $16,000 in interest only. The next thing we're going to look at is the future value. So if we have an investment, which is represented by PV, then we can use that investment and the rate and the time to calculate what the amount will be worth in the future. So in the question, Mike invested his summer earnings of $3,000 in a savings account for college. The account pays 2.5% interest. Find the future value in 9 months. So in this case, the PV is going to equal $3,000. The R is going to equal 0.025. And the T is going to equal 9 over 12 because I need to convert months into years. So 9 divided by 12 is 0.75. Now let's plug everything in. The future value, or the amount that you will have at the end of 9 months, is equal to the $3,000 of the initial investment times 1 plus the rate, and I'm going to put rate in parentheses, 0.025, times the time, which is 0.75. So putting that in my calculator, I need to make sure that I use order of operations. So I've got to go into my parentheses first and use order of operations, which means to multiply left to right. So I multiply 0.75 times 0.025, and then I add 1. So I have $3,000 times 1.01875, and that gives me $3,056.25. So, looking at the question and making sure this makes sense, the future value after 9 months, if I invest $3,000, means I'll have $3,056. Or I've earned $56.25 worth of interest. Now sometimes we will know what the future value is, and we need to find the present value. So the present value is the amount that's invested or borrowed at the beginning of the period. So let's look at this example. A company ordered 7 new computers for $5,104 each. They will not be delivered for another 7 months. What amount should the company deposit in an account paying 6.42% today to have enough to pay for them? And so we want to know what the present value should be. We have the future value because in 7 months we are going to owe $5,104 times 7. So that means that we're actually going to owe 7 times $5,104, which equals $35,728. This is our future value that we will owe in 7 months. We want to know how much do we invest today in order to have this amount in 7 months. So I'm trying to find my present value. Well, the formula is present value equals the future value over 1 plus RT. So present value equals the future value, FV, which is $35,728, divided by 1 plus R. Well, the rate in this case is 0.0642 times T, and T is 7 months, or 7 divided by 12. Now, multiplying everything out, we need to find what the number in our denominator is first. And that means we need to multiply 0.0642 times 7 over 12. So 7 divided by 12 is 0.5833 times 0.0642 plus 1. And that gives us 1.03745. And on top I have my future value of $35,728. Now, you'll have to clear your calculator and plug in $35,728 and divide that by 0.03745. You'll get an amount of $34,438.28. Now you need to make sure this makes sense. Does it make sense to invest this amount in order to have $35,000 in the future? Yes, it does, because you'll invest less now in order to have $35,000 in the future. So this is my present value, and it's the amount that the company needs to invest in order to have what they need to pay for those computers in 7 months. So let's look at the formula for compound interest. FV stands for the future value, the amount you have in the future. P stands for the principal, that's the amount that's invested, also known as the present value, but we call it principal in finance. I stands for the rate per period. Now, notice that the rate, the interest rate, is not labeled as R. That's because a calculation needs to be made in order to apply the interest every single period. So, for example, if you have a 4% interest rate, compounded quarterly, that means that you are going to earn 4% divided by 4 every single quarter. So I is equal to the rate divided by the number of periods per year. In this case, it's 4. Now, N stands for the total number of periods that you are compounding. So if you're compounding quarterly, which is 4 times a year, times 10 years, that means that you are compounding 40 times during the term. So our two new variables here are I and N. So let's start with an example. This chart shows the average interest rate earned on a fund called S&P 500 Index. The S&P 500 Index Fund is a fund that invests in the 500 top U.S. companies. Since 1959, the average has been 6.94% interest earned. So let's say the average is 7%. And we want to invest $1,000 now into this fund, which compounds monthly. How much will this $1,000 grow to at the end of 40 years? So we're going to use the compound interest formula, which is FV is equal to P times 1 plus I to the n power. So P is the principal, the amount that you invest, and that equals $1,000. The interest rate, or R, we're going to pull from the last slide, which is 0.07, which is the average interest earned on the S&P 500 index. But of course our formula has I, so we need to convert that to I. So I is the rate, 0.07, divided by how many times the amount is compounded per year. It compounds monthly, so that means the number of times compounded is 12 per year. And lastly, the N is related to the time. The time is 40 years. But of course, N is that time multiplied times the number of times that it's compounded per year. So the number of periods that we have during the term is actually 480 periods. So now we're ready to plug everything in. The future value of this investment of $1,000 is 1,000 times the principal, the amount invested, times 1 plus the I, interest rate, which is 0.07 divided by 12, raised to the n power, which is 480. Now, applying order of operations means that I need to go into my parentheses and do that first. So I have to divide 0.07 by 12 in my calculator and then add 1. Then I need to raise that to the 480th power. So it looks like 1,000 times 1.005833. Now keep this in your calculator and hit the y to the x key and plug in 480. So you should get 1,000 times 16.3114. And multiplying those two together gives me 16,311.41. That's the amount that I will have if I invest $1,000 today and wait for 40 years. Now let's say I waited 20 years to invest that $1,000. How much will it be? Well, my time is going to be 20 instead of 40. Everything else will stay the same. My principal is 1,000. The I is going to be 0.07 divided by 12. And my N, instead of 40 times 12, it's going to be 20 times 12. So that's going to be 240. So I have 1,000 times 1 plus 0.07 divided by 12 raised to the 240th power. Or, calculating that out, I get $4,038.74. So if I wait 20 years in order to invest that same $1,000, I will have about $12,000 less. So time is really what helps in compounding. So let's try another problem. Find the compound amount and interest earned. So the first thing we're going to do is find the compound amount. And what that means is find the future value. So I have $9,100 at 6.1% compounded quarterly. Now quarterly means 4 times a year for 8 years. So my P, the principal, is 9,100. My rate is 0.061, which makes the I 0.061 divided by 4, since it's compounded 4 times a year. And then my t, the time, is 8 years, which makes my n equal 8 times 4. So the number of periods is going to be 32. And now plugging everything in, the future value is equal to the principal times 1 plus I, which is 0.061 divided by 4, raised to the n power, 32. So put this in your calculator and try calculating it out on your own. Put 0.061 divided by 4 first, and then add 1. Raise that to the 32nd power by using the y to the x key, and then multiply that by 9100. When you do that, you should get $14,769. So the compound amount, the amount you have at the end of the term, which is 8 years, is $14,769. The interest earned then at the end of that term is going to be the $14,000 minus the initial investment of $9,100. So the amount of interest that you have earned over 8 years is $5,669.90. The next thing we're going to look at is continuous compounding. Continuous compounding means that it's not compounding 4 times a year, it's not compounding 12 times a year or monthly, it's compounding continuously, it's always compounding. And so with continuous compounding, you're going to have a little bit more come out as your future value. I'm going to pull out my principal first, which is $15,000. The rate and time is what I'm going to use in this case, so it makes things a little bit simpler. The rate is 0.029 and the time is 10 years. And so plugging everything in, my future value then is the principal times e to the RT. Now I'm going to put parentheses around r, 0.029 times t, which is 10. And now I need to make sure I put this in my calculator correctly. So in your calculator, you need to find out what this exponent is first. Multiply 0.029 times 10 and hit equals. Then you need to raise e to that power. In order to do that on a Texas Instruments calculator, you need to hit the second ln key, and that'll give you e to the x key. That's what you're looking for. So you have your exponent, you then use your second ln to raise it to that power, and then you multiply it times 15,000. So you should have $20,046 at the end of 10 years. That's the compound amount. So we need to make sure we answer the question, which asks two things: find the compound amount and the interest earned. Now to find the interest earned, all I need to do is subtract 15,000 from my compound amount, which means that I've earned $5,046 from this investment. So we're going to look at another compound interest problem, and in this case we're going to find the principal invested knowing the future value. So Bill wants to have $20,000 in the future, available 5 years for a down payment on a house. How much should he invest now if he can get an interest rate of 5.5% compounded quarterly? And so let's pull out the information first. The future value is $20,000 because he wants to have $20,000 in 5 years. My time is 5 years, or 5. And that makes my n 5 times the number of times compounded yearly. So this is going to be compounded quarterly, and quarterly means it's compounded 4 times a year. So 5 times 4, which is 20. And then my I is going to be the rate times the number of times compounded per year. So the rate is 0.055. Then I is going to equal 0.055 divided by 4, the number of times compounded per year. So plugging that into my formula, the amount invested, or P, is equal to the future value, the amount that I want in the future after 5 years, divided by 1 plus I, which is 0.055, divided by 4. And all that raised to the n power, which is 20. Now try this on your calculator with me to make sure that you get the same answer. This will be good practice. So order of operations says in my calculator, I need to start with the denominator and find that number first. So I'll keep my 20,000 on the top and divide that by, let's find the number together, so 0.055 divided by 4 equals, add 1, and raise that to the 20th power, so use your y to the x key, y to the x 20 equals. So on the bottom you have 1.31406. You want to go out as much as you can to make it as accurate as you can. So I'm going to have to clear that out and put in $20,000 and divide it by 1.31406. And I get $15,220 and take it out to the cents. So in this case it's 0.00, so there's no cents involved. Could be 0.01. But that's how much I'm going to need to invest now in order to have $20,000 after 5 years at 5.5% interest. So try practicing these again with your calculator, and be sure to watch part 2 of chapter 5 where we look at ordinary annuities and amortization.